afternoon all. Today we will discuss the final topic of this course. But I'm not saying that this is the final class. Later on we can revise, obviously, into the most important topics, and we have also some other things to do that I will announce later. But today we are actually we will discuss the final topic. This is MANOVA. In the previous class we talked about two-way ANOVA. Okay, and in case of ANOVA we have seen that there are one independent. In case of one-way ANOVA, we have seen that there is one independent variable and one dependent variable. In case of two-way ANOVA, we have seen two independent variable and one dependent variable. Similarly, in case of three-way ANOVA, there will be three independent variables and one dependent variable. But in case of MANOVA, MANOVA means multivariate analysis of variance. Whenever you term MANOVA, it starts from two-way MANOVA. That means you will have at least two dependent variables, and there will be one independent variable. And if you have more than, you can also have more than two dependent variables. That will be known as three-way MANOVA. And also you can have many dependent variables and many independent variables. That also can have. Okay. So, but there is no such thing called one-way MANOVA, because if it is one-way MANOVA, then it will be converted, or it will be equal to, or it will be equivalent to one-way, simply one-way MANOVA, because there will be one dependent variable and one independent variables. Okay. So now you need to know what is the purpose of MANOVA. Okay. So just have a look at this picture. This is the idea will be very clear. You can see here that in case of one-way ANOVA, you had one dependent variable and one independent variable, and you are trying to find out the association between, suppose for example, your x1 or your independent variable is different types of teaching methods. Suppose M1, M2 and M3. So you are trying to, and suppose your dependent variable is a test score. Okay. So you are trying to find out what is the effect of different teaching methods on test score, or whether your the teaching methods are statistically significant or not. Okay. Or what are the effects or influence of different teaching methods on test score, that you are trying to find out. In case of two-way ANOVA, you have two independent variables. Okay. M1, suppose x1 and x2. X1 is suppose different teaching methods, and suppose x2 is your gender, which could be male and female. and you are trying to find out what is the association or effect of different teaching methods on the on your response variable, that is your test score. What is the effect of gender on your on the test score, and also you can find out that what are the interaction effects of teaching methods and gender on the test score, that you can also check out. But think about this case of two-way maneuver. There is one independent variable, for example, the teaching method, and there are two dependent variables. Okay, one is suppose satisfaction, y1 it is test score, and y2 is satisfaction score, and you want to test the association between different teaching methods on the relationship between satisfaction and test score. So this is what you can see in this case of two-way maneuver. Let's take a look at an example. The idea will be clear. Maneuver can detect patterns between multiple dependent variables, but what does that mean exactly? It sounds complex, but graphs make it easy to understand. Let's work through an example that compares ANOVA to MANOVA. Suppose we are studying three different teaching methods for a course. This variable is our independent variable. We also have student satisfaction scores and test scores. These variables are our dependent variables. We want to determine whether the mean scores for satisfaction and tests differ between the three teaching methods. We want to determine whether the mean scores for satisfaction and tests differ between the three teaching methods. That means if you apply three different teaching methods, whether you will get different means of satisfactions or different means of test scores, okay, or whether you will be having exactly same satisfaction scores or test score, or not all mean are equal, that you would like to test here. The graph below displays the scores by teaching method. One chart shows the test scores and other shows the satisfaction scores. These plots represent how one-way ANOVA tests the data, one dependent variable at a time. Okay. Just take a look at this graph. These graphs. Okay. So this is individual value plot of test, and this is individual value plot of satisfaction. So along x-axis here, you are representing different teaching methods, and along y-axis you are representing the test scores. Here along x-axis you are representing different teaching methods, along y-axis you are representing satisfaction scores. So both of these graphs appear to show that there is no association between teaching method and either test scores or satisfaction score. The groups seem to be approximately equal. Okay. So what you can see here, that the teaching methods different teaching methods, you can see you cannot if you just have a look at a glance, what you can conclude from this graph? Can you conclude that a particular teaching method is providing higher value of test scores? No, not like that. They are all very scattered in nature. Okay, so it means teaching methods, they do not have effect on the different teaching methods. They do not have the effect on the test score. As you can see or observe, from the graph.
Mhm.
Similarly, you can also see that the data for different teaching methods in terms of the satisfaction score, they are also very scattered in nature. That means you cannot say that one particular teaching method or some particular teaching methods provide higher satisfaction scores. So that is said here. The groups seem to be approximately equal or more or less equal. Consequently, it's no surprise that one-way ANOVA p-values for both test and satisfaction scores are insignificant, 0.923 and 0.254 respectively. So here in this case 0.923, which is greater than 0.05. Here also it is 0.254, which is greater than 0.05. So at 95% confidence level, you can conclude they are insignificant. Even greater than 95% confidence level, you will find that they are insignificant. These teaching methods, they are actually insignificant. Case closed, the teaching method isn't related to either satisfaction or test scores. Hold on, there is more to this story. Okay, what is this story that we see in the next slide? In this graph, scatter plot of test versus satisfaction scores are provided. That is, along x-axis you are representing different satisfaction scores, and along y-axis you are representing different test scores. And what you can see, the graph displays a positive correlation between test scores and satisfaction. That means the more the satisfaction score increases, test score also is also increasing. Okay, as student satisfaction increases, test scores tend to increase as well. Moreover, for any given satisfaction score, teaching method 3 tends to have higher test scores than methods 1 and 2. So here you can see that for a given satisfaction level, teaching method 3 will provide the highest test scores in most of the cases, or in majority of the cases. Because you can see that the blue dots are relatively at the lower side, red dots, they are at moderate level, and the green dots, they are at the higher side in majority of the cases. So that's why the teaching for a particular, you can conclude that for a particular satisfaction level, teaching method 3 will provide highest test score than teaching method 1 and 2. So in other words, students who are equally satisfied with the course tend to have higher scores with method 3. MANOVA can test this pattern statistically to help ensure that it's not present by chance. So just have a look at this graph. Suppose if you draw a line, and if you just notice the points that is line here, here, and here, everywhere the satisfaction scores will be same, but the corresponding test score that you will have in this graph, for example, for this particular satisfaction score, your test score will be somewhere here. For example, parallelly, your this particular satisfaction scores, your test score can be higher. This particular satisfaction scores, tests can be higher. These things can happen. This is actually what they are trying to say. So what you need to do, you need to basically calculate the MANOVA test statistic, which is given by this formula. And also, you need to understand that it is when you are calculating, when you are evaluating the extremeness, due to the multivariate nature, there is no single or unique solution for extremeness. And there are several tests: Pillai stress, Wilks lambda, Hotelling lolly stress, Roy's largest root. These are actually used to evaluate the extremeness. Just take a look at this output. Suppose you are performing some analysis using MANOVA. Okay. So what kind of, using Minitab. You are performing MANOVA using, suppose, Minitab software. So then what kind of outputs you will get? You will get this sort of outputs. Even though the one-way ANOVA results are graphs seem to indicate that there is nothing of interest, MANOVA produces statistically significant results as significant by the minor scale p-values. We can conclude that there is an association between teaching method and the relationship between the dependent variables. So if you have a look at this method, Wilkes test, Lolly, Pillai test, Roy's test. Test statistics are provided. Different F values are also provided. The degrees of freedom are given. Closest F values are given for the test statistic. Closest F values are given, and you can see that the p values are also provided. You just have to look at the p values, whether to understand whether it is significant or not. Okay. So closest F values are given for the test statistics here. Now you just have a look at, you just need to look at the p values. Now when MANOVA provides benefits, use multivariate ANOVA. So you can see that in this case, the relationship is significant. You can conclude that there is an association between teaching method and the relationship between the dependent variables. So your ultimate conclusion is that though there is no association between teaching method and test score, or the teaching method and the satisfaction score, but there is an association between teaching method and the relationship between the dependent variables. That's why p is less than 0.05. So when MANOVA provides benefits, use multivariate ANOVA or MANOVA when your dependent variables are correlated. The correlation structure between the dependent variables provides additional information to the model, which gives MANOVA enhanced capabilities. So basically MANOVA is used when actually your dependent variables are correlated, then or significantly correlated, then MANOVA is basically used, because there you will have higher chance that you might get probability, the p values is less than 0.05. Just like you can see that previous example, that here the relationship between the two dependent variables, satisfaction and test scores, they had the relationship in between. Okay. So that's why if the relationship exists, then you need to understand, you need to know that how the independent variable is affecting the relationship or influencing the relationship. Okay, but if there is no relation between the test score and satisfaction score, then there is no point of observing what is the relationship between uh, uh, the what is the relationship between the independent variable and dependent on the relationship of the dependent variable. What is the association that you don't need to check. So this is actually maneuver. So this is just some primary things. You know, maneuver is very complicated. Maneuver is not that much easy to understand. But this is the primary things how to look of maneuver. But usually the things that you apply for your analysis purpose when you will do your project work like those things, then basically you mainly you deal with ANOVA. Okay, maybe two-way ANOVA or three-way ANOVA, like that you use. So we have completed the part of, we have completed the course. All the courses are completed. The other things, structural equation modeling and those things are not required. So if possible, then I will take hardly one or two more classes. I will take for to make you understand more about ANOVA, because ANOVA is very important for you. This project I can discuss with all of you. So hardly it will take two or three classes maximum, and